So let's go through the homework solutions from the homework you had last Friday, where you were asked to draw a net of several shapes, calculate the surface area and calculate the volume. So they're all three-dimensional shapes. Now, as you'll recall from junior cert, when we're calculating or when we're drawing a net of a shape like this, it's useful to think about the front and the back, which match. So the front will always match the back. The top will match the bottom. And then you've two sides as well, side 1 and side 2. You might have called them left and right, I'm not sure. Pick a face to start with. So I will usually start with the front and sketch out the rectangle that represents the front. And it doesn't have to be to scale. They don't have to be in proportion. You just have to label the different sides. So this is going to be the front. And I know that it's 2 meters along this way and that it's 1.3 meters up here because there's the height. There's the other side of that. Then if I'm going around it, I can see that the front is attached onto the top. So the top is actually not quite as big. So the top like this is 0.8 going across here because that distance there and that distance there are the same. And the top and the bottom match each other. So the bottom coming along here, also 0.8. And then I can either put the back up here or the back down here. It doesn't really matter. So the back along like this, and the back matches the front as we wrote down here. So that's 1.3 meters as well. Then I need to stick on the two sides, and I usually stick them onto the front like this. So side 1 and side 2. And what are the dimensions going to be here? Now, I could have drawn this a little bit more accurately, but we know that this distance here should match this distance here. So that should be 0.8. And that going up and down here will have to match on the front, so 1.3 there. So this allows me to very quickly calculate the surface area. The front and the back are the same, so I have two of them.
Excuse me, teachers and students, a short announcement for our really close students today, please. Students, you will receive an email from Ms. Kerrigan with regard to the assessments moving forward. As Ms. Kerrigan announced last Tuesday evening when we met with you and your parents, there will be two assessment windows. On the email that you will receive from Ms. Kerrigan, you will find a schedule for your assessment windows on the week of Monday the 15th of March, continuing on until the end of the next week. So that is assessment windows.
Now apologies, I can't pause this video, I don't think. Let me just see if I can. No, I can't pause this without stopping the video completely. So just bear with me please till the announcement is finished and then I'll go through what I've done here. I'll do these calculations. Hopefully you can see where I'm getting them from.
Students, I want you to familiarise yourself with those assessment schedules, and I want you to make sure that if you have any appointments outside of school, that they are planned outside of that assessment window. It's very important that you are here with your teachers engaged in this process. The second part of the email identifies the Reading Cert experience. It goes through what dates the Reading Cert experience will take place, and you are asked to complete a Google form that's highlighted in green. And in that form, you will indicate which exams you want to take for your Reading Cert experience in private King. The next point of the email is asking students who are going to engage with the portal this week. Now the portal, as I said last week, girls, it is recommended that every single student engages with the portal. So every single student logs on and engages with this portal this week. This is critically important to you. If you have any concerns about filling out the portal...
Okay, so like I said, I'll go through this in a second when the announcements are finished because I don't want to have the two of us talking at once. So I'll just draw out the next diagram before I go through this in detail. Now, okay, so to go back through the steps of what I did here, we're finding the surface area. So the surface area of the front is going to be the length by the width, which is 2 by 1.3, but there's 2 of them because the front and the back are the same. So that's where I get this number from. Same thing for the bottom and the top. They are 0.8 by 2, and there's 2 of them. And finally the sides, each of the sides, it's 1.3 by 0.8, and there's 2 of those. So I work out those individual areas and then I add them all together to get my total surface area. One thing that I didn't do is, of course, the volume. And the volume of a cuboid is just the length by the width by the height. So in this case, that will be 2 by 0.8 by 1.3, and that is going to be 2.08 meters cubed. Now, it's really important that you put in your units and you put in the correct units. Each of these dimensions was in meters, so the area is meters squared and the volume is meters cubed. So hopefully you were all able to work that one out. Next, we had a triangular prism, and it's a triangular prism with an equilateral triangle. So that means that, again, we've got our rectangular faces here, and they're all the same because it's an equilateral triangle. So once I start sketching this out, I can just maybe start with the bottom. They're all going to be the same length. So we've got the bottom, and then we've got the other 2 sides, and they should all be the same. They should all be identical. And in an exam, you'd use a ruler, but when you're just sketching these for homework, it's fine to draw them freehand. And what are the dimensions that we have? Well, we know that this is 2.5 because that's the distance along there, and we know that each of these are the same and that they are all 2 meters. So we have everything that we need there. And what about the triangular faces? Well, we've got to stick those on. So there's one triangular face and there's another triangular face. Now, in terms of calculating the surface area, it's easy enough to do the sides. The sides are all the same. So side 1 is equal to side 2. The 2 sides are the same, which is equal to the bottom. So we will have 3 by the length and the width of those, 2 by 2.5. But what about the triangular faces? So the front and the back are going to be equal, but how do we find out their area? Well, their area is going to be half the base multiplied by the perpendicular height. So we've got an extra little bit of work to do here. We need to sketch out one of those end face triangles. They're equilateral, so I can divide it into 2 equal right-angled triangles and use Pythagoras Theorem to find the perpendicular height. That's not 2. Apologies. That's 1 because I've divided it in 2. So that's 1. That's 2. And so I can work out that perpendicular height using Pythagoras Theorem, that the perpendicular height squared plus half the base squared will be equal to the hypotenuse squared. And h squared is equal to 4 minus 1, which is 3. So the perpendicular height is the square root of 3. And it's fine to leave it in third form. So this area here is going to be a half by the base, 2, by the perpendicular height, which is the square root of 3. And that actually works out, because those guys cancel, to be the square root of 3 meters squared. Don't forget that I have 2 of them, of course. So multiplied by 2 because 2 triangles. Because I have 2 triangles. So that means that I've got 2 times the square root of 3 meters squared. And we'll leave that one like that. These ones, I had 3 of them. So that's 3 by 2 by 2.5, which gives us 15 meters squared here. And my total surface area, let's start to use this abbreviation now. Total surface area is going to be 15 plus 2 root 3 meters squared. And you can leave it like that unless the question asks you to do anything different. So let's just check. Correct to one place of decimals. So we do have to change this to a decimal. And I just do prefer to do this at the end because then you don't have any rounding errors. But if you substituted a decimal earlier than this, that's fine as well. So put that into my calculator, press my change button, and I get 18.5 meters squared to one decimal place. 18.5 meters squared. Now, in terms of the volume of a prism is going to be the area of the end face, so area of my triangle, multiplied by the length. That's the formula that we have for the volume of a prism. And we've already calculated the area of one of the end faces. It is √3 meters squared. This was when it was two of them. So that's going to be the square root of 3 multiplied by 2.5. 2.5 is the length of my prism. And we'll put that into our calculator and change it to one place of decimals immediately. And don't forget that it is meters cubed. So 2.5 by the square root of 3 gives me 4.3 meters cubed. 4.3 meters cubed. So there we go, surface area of a triangular prism. Let's go on to the next one then. We had a rhombus. How do I know it's a rhombus? Because all four sides are told to be the same. We sketch a quick picture of it. It's just a skewed square. And they're kind to us and told us the perpendicular height here is 8 centimeters. There's the rest of it, like that, and that's 10 centimeters. So again, they want us to sketch out a net of this. Remember, all faces here are the same size. So I'm going to do exactly the same thing as I would have done with my rectangle, except they're slanted. So here's my front. Here's the front. It's a rhombus, so that's 10. And also, that's 10. And then the top is exactly the same size. Exactly the same size. Also, 10 going all the way along here. I should have used a ruler for this, maybe. 10. It's fine to just sketch it out like this while we're getting used to it. Front, top, bottom, and the back. So we're just continuing along the line. Back, and also 10 and 10 along here. So then stick on the two sides wherever you feel like, and they are the same as each other as well. So it's like a cube, and we've kind of skewed it. Side 1, side 2, 10, 10. Everything is 10 here because it is a rhombus. So in terms of finding the area, well, we have 6 faces here and they all have the same area. So my surface area here will be 6 times 1 rhombus face. 6 of them. And the area of one rhombus, they're parallelograms, is the base multiplied by the perpendicular height with no half because it's not a triangle, and that's 10 times 8 because they told us the perpendicular height, and that's 80 centimeters squared, and then there are 6 of them. So the total surface area is going to be 6 by 80. 6 by 80. And that is 480 centimeters squared. What about the volume? Well, it is a prism, so we can still use our prism formula for the volume, but it's the area of an end face multiplied by the length. We've calculated the area of one end face as 80, and the length is 10 centimeters. So that is 800 centimeters cubed for the volume. That was part C. Okay, so long as that's skewed, you don't have to be super accurate, you don't have to keep these to scale. Getting it done quickly and getting the basic shape down is what you're looking for here. Okay, so the final one then was two things stuck together. We had a triangular prism sitting on top of a rectangular prism, or cuboid if you prefer. So a house shape. And the information we were given was that this was 7 centimeters and that these were all the same. So of course this is 7 centimeters and this is 7 centimeters. And this is 20 centimeters. And we're also told that these lengths are the same despite how I've drawn it. So this must be 7 centimeters as well. Sorry, I was off the screen there when I was sketching it, sorry. So in terms of drawing a net of this, what I would do is I'd take the front of it. We've got our 20 centimeters going down like this, our 7 centimeters going across, so 7, 20, 7 diagonal height. And then I'd fold out these parts here. So we would have 7 and 20 and 7. So remember, these are all the same. And that stays as being 20. And I'll do the same on the other side. Fold out those flaps. 7, 20, 20, 20, all going across like that. And what will we do about these rectangles here? Well, whatever, you could stick them onto the triangle. Might be a little bit neater to stick them on here though. So that height is 7 as well. Like I keep repeating, they don't have to be to scale. It's just getting the basic idea of it, and that's 7 and that's 7 as well, because those are all the same length. So there's my net. And we have, let's label them 1 and 2. So those two rectangles are the same. And if I'm doing their surface area, 1 and 2 are the same. So the surface area will be twice. Let's call these 3, 4 and 5, and they're all the same as well. They're all 20 by 7. So this is 7 by 7, they're little squares. So 3, 4 and 5 are the same. So I have 3 times 7 by 20, which is 21 by 20, 420 centimeters squared. And of course I have to work out my triangle separately, just like I've done before. So I'm going to divide it into 2 equal right-angled triangles and use that to find my perpendicular height. That's 3.5, that's 7. So 3.5 squared plus my perpendicular height squared will be 7 squared. My perpendicular height squared will be 49 minus 3.5 squared. And we get 36.75, which means that my perpendicular height here will be the square root of 36.75. This is Pythagoras Theorem, and you should be familiar with it. The square root of 36.75, and that is 6.06. We'll go to 2 decimal places while we're working out. Centimeters. So I've got 2 triangles, don't I? Yes, my net is missing, my second triangle down here. So apologies for that. So face 6 and face 7 are the same. 6 is equal to 7. And I've got twice half the base. The base is 7 by the perpendicular height, 606. So we get, multiply that by 7, 42.43, 42.44, but 1 decimal place is fine now because all I'm going to do after this is add them. 42.4 centimeters squared for my triangular area. And my total surface area total surface area here is those three added together. So that plus 420 plus 98 gives us 560.4 centimetres squared. So that's my total surface area. And can I fit the volume in here? I need a new page. That's my total surface area. So the volume then is the volume of the two parts. This one's volume will be 7 by 7 by 20, which works out to be 49 by 20, 49 by 20, 980 centimetres cubed. And this one is going to be the area of the end face, so the 42.4, volume equal to 42.4 multiplied by the length, which is 7. So that's that volume is 296.8 centimetres cubed, meaning that my total volume, so this is a bit messy, but you can see the calculations, you're following it along. Total volume, so the two of those added together, 296.8 plus 980, which gives us 296.8 plus 980, 1,276.8 centimetres cubed. Okay, so these questions, they're a little bit long, they're a little bit finicky, but they're not really difficult once you can visualize the three-dimensional object folded out flat. And remember, with triangles, you're going to need to divide them into right-angled triangles and use Pythagoras Theorem to find the perpendicular height, just as you would have done for junior cert as well. Okay, thank you.